Hello YouTube viewers, welcome to my show Future Friday. In today's episode we're gonna continue our moon series, and today we're gonna take a closer look at moon landing site. So a brief overview you have to understand about landing spots is that we just don't pick them randomly. There has to be a lot of consideration, a lot of data gathering before we make any decision. And each spot, no matter what you want to do, each spot will give you some pros and some cons. Let's say you want to study the geological aspects of moon. You want to land inside a crater, but let's say you want to study the basically sky using the moon itself. You want to land in a place where you get clear view of the sky. That won't be in the bottom of a crater because the horizon will be blocked by the rims of the crater. So every place that you can choose on moon will have some pros and some cons. So you have to figure it out based on the mission parameter. So all the mission that we went on moon using Apollo project, they were carefully selected for that kind of mission. They were like, okay, we are going to the moon for a national reason, might as well do some science with it. That's why not everything is landed in the same spot. So in recent discussion, everybody wants to go to the pole. Now, why they want to go to the pole? First reason, core reason is it has 24/7 power. Now you have to understand, at pole you are not actually spinning. You are at equator, you are spinning very fast, but as you get closer to the pole, you are technically not spinning. Now of course you are still spinning, you are going like this, but you're not spinning very fast, so you don't have that day and night cycle. And on top of that, there are certain places, because there has a crater been created recently, and recently I mean few million years, the rim of the crater is so damn high that at that place there is 24/7 power. Basically you put solar panel there, done, you're gonna get 24/7 into 365 power. So that is very crucial. Like, you want to survive in space, you need matter and you need energy, and that takes care of the energy aspect. On top of that, because the depth of the craters does not receive sunlight, there used to be thought that there might be ice there, but it's a recent advancement in our astrophysics and the fact that India crashed basically impact probe into that and finally figured it out. Yes, there is ice there. Like, there is no discussion about it. Question is how much is there now. Now some people suggest there are a few hundred tons to a few million tons, but it's basically, to give you the context of that, it's basically from a small pond to a large lake, but it's not a sea level. Do not think it has more than enough water. If humans go there and if we truly start to do something, we're gonna run these places dry very quickly. So that is also the second reason. Like, if you can bring the water right directly from there, it's amazing. You can make rocket fuel from them and you can survive based on that. And there is one consequence of that. That area is very small. That rim of the crater that I'm talking about, where you have 24/7 light, if you have to take a basically lander and you have to land it exactly there, good luck with that, because at that scale, like I'm talking like traveling at orbital velocity and then slowing yourself down and directly trying to land there, it's very tedious. Even a computer will have hard time processing that kind of information and making sure the landing is correct. And the biggest hurdle with that, it's not that computer can't do it, it's simply because if you have any plus and minus anything that happens, the leeway to recovery is zero. Basically you have to land on top of a Mount Everest. That's what you are trying to do. Basically a bad idea. You don't land your helicopter on top of Mount Everest. That does not work. So that is the first aspect. And on top of that, the area, overall that area that is exposed to sunlight will give you few good megawatts, but not hundreds and thousands of megawatts if you want to industrialize the moon. So the total area benefit is not that great. And in terms of orbital mechanics, landing there is a bit more trickier than landing near equator. That's why if you see all of the Apollo mission, you will see it's more like a circle from, like, let's say this is the equator, they made more or less circle. Going to the pole is very difficult, be it Mars, be it moon. Going to the pole requires a bit of extra tigadum. So this is the aspect of the pole. That's why everybody wants to go there, but nobody really can afford to go there, because it's a very small surface area. So basically your landing will have no margin of error, and it's very hard to land because you are trying to land on top of a Mount Everest. So, and what are the risks involved when you are talking about moon? Now, of course, there are some obvious risks: radiation shielding, water. Basically, you don't have everything. You have to bring everything with you at first, and on top of that, you have to worry about vacuum and basically other things of that nature. Now, on top of that, because moon has some gravity, it has basically become a shooting gallery. Basically, it's getting bombarded by asteroid, meteorites 24/7 into 365. Generally, because moon's super large surface area, it does not affect any small site. But if you are trying to spread on top of moon, either you do it underground, and when I say underground, I really mean underground, and I'm not talking like few meters of regular is gonna protect you. You have to go kilometers deep to make sure, because impacts that happen on moon surface, that can range from minor inconvenience to like, yeah, it's a big ass nuclear warhead. Because recently a lunar impact was captured on camera throughout the planet, and I have provided the link down below. Is that it was so bright, the impact was so bright, it was seen from Earth using normal minor telescope and normal cameras. It happened during eclipse, and you have to understand this. It is so bright that you can see it using normal camera from 300,000 kilometers. Let that sink in. It's 1 light second apart, and it was not a laser that was pointed to us. So just try to understand the impact, basically the impact energy there. It's very powerful, and there are specific telescopes, there are specific probes that we have that is just sole job is there to detect this thing. They detect this almost hourly basis. Now, of course, not this big every hour, but this does happen. There are small dedicated telescope that do detect it. So even though, let's say, you are not detecting it every day, and you might be like, okay, that means only small one happening. Yeah, small one too for you and us, but for somebody living on the moon, yeah, that small one is like a giant basically kinetic kill warhead. It's gonna destroy anything it hits. You're talking about moving at a multiple of 10 km per second. It's gonna destroy anything it touches. So impact has to be taken into serious consideration. At early stages, we cannot go deep underground. Even though we want to, it's just not feasible. So early stages, we simply gonna employ a lot of radar station covering the whole moon and give us a very good coverage and figure out where the impact's gonna happen. On top of that, the surface is basically not stable because we haven't actually landed there and stayed there for a very long amount of time. So that way we do not know what kind of impact the temperature has, because you have to understand day-night cycle is 15 days long, and how eclipse affects these things. There are other things that happens. We don't have enough data, and on top of that, because it's kind of sandy, if you really want to understand the surface of the moon, it's more or less like a desert. It's literally not very stable. Then comes the basically big daddy, solar flares. Now, we are ludicrously lucky that all the moon mission we had, no solar flare happened in the direction of basically Earth and moon. If that happened, astronauts would have been radiation poisoned instantaneously. So, but there is one good thing about it. Even though this is very powerful and very radioactive, and like very charged particle in them is like very dangerous to living creatures, it cannot go through the moon. Basically, let's say this side of the moon is exposed to solar radiation and solar spectrum, solar flares. Basically, it will not go through the other side. It is not that powerful. Basically, even if you are below the regular surface, let's say below few meters, it will not harm you. However, if you are on the other side, no matter what happens, it cannot touch you. The benefit of solar flare is that even though our detectors can detect it, and even though this is moving 15% speed of light, we can transmit signal at light speed. So we get quite early warning when it comes to solar flare. And I'm talking about early warning in sense of like, not that it's gonna happen 10 days from now. Oh, it happened, solar flare happened, it's coming to you. This is the ETA, 2 minutes, 5 minutes, 8 minutes, whatever have you. So we receive the signal from sun, let's say in 8 minutes, the solar flare will take you upwards of around 15-16 minutes. So we do get 10 minutes of warning, which in case of International Space Station is long enough warning that they will be put into the central area where they have a lot of water bags to act as a radiation shelter. So that is the reason you want to have something where you can go either deep into the moon or on the other side. At the other side, you are perfectly safe. No matter how powerful this becomes, it will not reach the other side. Basically, if you are in the shadow of the moon itself, you are protected, 100% protected. So these are the risks, not a small risk. So how are we going to tackle it? If you really want to make humanity last on moon, we have to have 3 landing sites. Now, the reason for 3 landing sites is the same as why we have 3 phase. Basically, at any moment in time, you will have solar farm, whatever working in the 3 place. One would be at 100% power capacity, which is nice. And if let's say you make every spot that you have, every spot of colony you have requires 10 megawatt of power, you're going to have 30 plus watt of solar panels. Simple reason, because whichever part is exposed to the full sunlight, it will provide the power throughout the moon. Basically, one side that is facing the sun, one side that is in the shadow, another side that is like in the twilight zone. So this way you always have power, and you always have surplus of power, which is necessary. If you are doing mining operation, spending that power is not an issue. You can easily spend it. It always will be underpowered, so you don't have to worry about excess power. And we will try to land it as close to basically Apollo missions. Basically, we'll try to go as high as like 60 degree but you really don't want to land on the pole because A, it's very difficult to, B, there is no margin of error, and this whole area is like very randomly littered with craters. So you want to be here, and we're gonna have three phases basically: site A, site B, and site C. Each site will be from, if you look from pole, you will see them 120-degree apart. That way, no matter what happens, there will be always one spot that will be in 24/7 sun power. If you have interconnection, then you will have one side that is 24/7 into night side. Now night side is very interesting for basically any type of astronomy which is working in optical spectrum. You really don't want to do the basically astronomy using optical spectrum when you are facing the sun. It's going to be very difficult. Can be done, but going to be very difficult. You want the best result, you want to do it at night, lunar night. And you want solar power, you want to have solar power basically. And this also allows us one crucial benefit. That says we detect, our radar station detect a meteoroid is hitting your way, and it's going to impact you, let's say in 8 hours or 9 hours. You basically have to evacuate. Now in early days we cannot go burrow underground, we don't have the technology yet. Now of course, even if we had the technology, it takes years to burrow down and build something. And when you are talking about building something that is airtight, absolutely sealed, yeah, that's going to take even longer. So for that reason, you have to evacuate. If you have three spots, one spot will be very close to you. No matter what happens, one spot will be close. And if that spot is also getting destroyed, you still have one another. So that is why you want to have three. Now, why not six? So why not eight? It's too expensive. I'm talking about moon mission. It's not going to be cheap. So three is a very good compromise. Like at any given moment in time, one spot will be very close to you. And heck, let's say you detect something, you can literally send people on the both ends. Like, you know, few people go here, few people go here, if you don't know which side will be impacted. So that way you can be sure and safe, which is necessary because people are living here. I'm talking about a manned mission, and I'm trying to make moon into industrial complex, not just like, oh, we went to the moon for recreation purpose. I'm talking about moon industrialized to a point where it actually allows human to unlock space. For that reason, three landing spots are necessary. On top of that, we have to interconnect them. As I already alluded to in last slide, is that these three to be connected in three core reasons: data, power, and transport has to be there. Now transport part we have already figured out. Data part we can rely on optical fiber, because of the optical fiber that is made in space, aka International Space Station, is multiple times better than what we can make on Earth. So even a very thin light cable of optical fiber will not weigh too much. Basically we are talking about 1 or 2 ton, and you can cover the moon with it. So, and that will allow you very good quality data transmission. If not, you can use laser communication that way, and laser you can have mirror at strategic places to bounce back, and you can make sure you have whole coverage of the moon with high enough bandwidth. On top of that, you need power. This is the biggest hurdle. How you gonna transmit megawatts of power? And I'm talking about the infrastructure in terms of how we have on Earth. Basically, something big, something robust, something that can take hundreds of megawatts. Of course, we're gonna lay down the foundation will be with 110 megawatts, something like that. But of course, it has to be capable enough of, you know, either it should be easy to upgrade, or it should be powerful enough from day one that we can keep expanding our solar farms until, like, you know, until very long in the future. So this power aspect is very tricky. Transport aspect, of course, the lunar rovers were built in such a way that if any failure happens, they must be able to, like, basically the astronaut must be able to walk back to the basically the lunar lander basically. So that's why they did not have as much of a basically luxury while they are building. And this was Gen 1. You have to understand, this is Gen 1. If we want to build it today, we can build that will go faster and they will go further using the same amount of energy. So we do have much better understanding, and the fact that there is low gravity and the fact there is no atmosphere does allow us some luxury. And the link, basically the link will be the physical link, optical fiber and power transmission, and you're gonna have lunar rovers or lunar train, who knows, these things. But these three spots must be interconnected. It is necessary that they are interconnected, otherwise this will not work. Then we come to the aspect of what are the issues of doing that. Well, first, the roads are not very smooth. It's not like you have paved road and you can go hundreds of miles per hour. So even though like moon rotates very slowly, you still have to travel, let's say every 7 days you have to move to a next spot. Or the people who are doing specific kind of astronomy, they will have a different timetable. Some astronauts who are figuring out basically, let's say visual astronomy, they will spot basically they will try to go A, B, C. If you have, they might be in B and they might be switching to A because A side will be now in the shadow. They will be switching like the people who are dealing with power, they will be switching in invert. So we have to figure out how do we have a large amount of people going from point A to point B without seriously bottlenecking and risking life. power transmission, this part I haven't figured out how to do properly, so that is a very big issue. And without power connection between each of them, the only way you can truly grow in moon is having a nuclear reactor, which is not practical for thousands of reasons. So for power reason, power transmission is necessary. Then we come to the aspect that if you're trying to build 3 of something, it's very hard to sell someone that, yeah, once we have this 3, this will work. But people will ask, like, why not just put all the eggs in one place? A, it's very risky. B, 2 is simply not enough. 3, it's a bit too expensive in terms of current budgets. Basically, you are talking about at least 5-6 SLS mission, at least 5-6 BFR mission per site, and you have to do 3 sites. And I'm not even thinking about like how you're gonna connect the power part. Everything else is super easy with current technology. Everything else is super easy. Power aspect will be tricky part. So without doing that, if we don't interconnect it properly, this mission will fail before it even gets off the ground. So if you have 3 landing sites, A, B and C, and if 3 are interconnected, it allows us a lot of safety, lot of redundancy, and a lot of power also. So this is my video about a lunar landing site for my imaginary mission. I hope you liked it, learned from it. In that case, please leave a like. If you didn't like it, you can click dislike. I would urge you to do so. And if you really want to help me out, please click the ad that are shown in this video. That will directly help me. Subscribe, press the bell icon if you're free. And as always, thanks for watching.